Okay, so in this little tutorial, I want to introduce the concept of resistance and how you can determine the resistance of something. Resistance is a key component to any circuit. It controls the current in a circuit. It determines how much power is developed in a load. But a question we have not addressed is what affects resistance. So before we go into the formal notes, I thought I'd look at a common appliance, a toaster element, and just kind of give you a background behind it. A toaster element is nothing more than wire, and that's what most resistors are. So let me just point out what this picture is. The flat part is mica. It's just a non-conductive material that distributes heat. The key thing about a toaster, the thing that glows if you look into it, are these wires that just basically wrap around that mica sheet. There's two on each side. Okay, so the first thing I want you to understand about resistance or resistors is most of them, at least the simple ones we're dealing with here, are nothing more than a wire. A wire might be wrapped around with ceramic material, or in this case mica, to, like I said, distribute heat, but usually it's nothing more than that. Now, even a classic incandescent bulb, Edison light bulb, is nothing more than a wire that gets so hot that it glows. In this case, it's a tungsten, which is for a light bulb is the key material. Okay, so let's think about this. Let's say we have a toaster. We want to build a toaster, okay? And we want to use that toaster to warm up our Pop-Tarts, okay? Very, very important start to the morning. So we want it to heat up quickly, so we want a lot of power. So the power output of a toaster, let's say, is 1200 watts. That's not atypical. Okay, so we also know we're going to plug it in, and we're in North America, so we know that the voltage is a standard 120 volts. You really don't have control over that. That's when we buy products at a store, it is assumed we're plugging it into a standard outlet, and so that's a given. So if I wanted 1200 watts and I got 120 volts as my source, that means I have to draw, right, P over V would be 10 amps. So we know there's going to be 10 amps going through that toaster when it's turned on. So how do we get the 10 amps? Well, that's determined by the resistance. So if we apply Ohm's law, we know that resistance, which is V over I, is going to be 12 ohms. Okay, so I need 12 ohms in this wire. So if I'm a manufacturer, how exactly do I know I get 12 ohms? What does that depend on? It doesn't depend on these. I want this, I know this, so to get this, I need that. To get the current, I need a specific resistance. So the big question is, how do I get that specific resistance? And that's what we're going to talk about. Normally we do a lab with this, but we can't this year, and there's not a good simulation one that would be worth the time. Okay, so let me just really quickly talk to you about what matters. Well, I would think the first thing that comes to your mind is what determines resistance is the material itself. And you kind of know this because you understand the concept of conductivity or insulators, conductors or insulators. You know that certain materials are good conductors, generally metals, and other materials are poor conductors, let's say plastic or wood or rubber materials. Okay, so when you understand that, that's in a sense an indirect measure of resistance. For a given, for everything else being equal, if you've got a length of wood and you've got a length of wire, you know that the wire is a better conductor, which means it has a low resistance compared to the wood. So let's say we choose a particular material here. Well, we want a lot of current, so it means we want a decent conductor. So we want our coil to be metal. The metal that we choose, in this case, is called nichrome. It's an alloy of nickel and chromium, and it has some cool properties. Two of the key properties of nichrome, and you don't have to know this, but I'll just fill in the information, is that it can get really, really hot and it doesn't melt. Secondly, it gets hot in the presence of oxygen, but it doesn't oxidize. Most metals, when you get them really warm in the presence of oxygen, they'll oxidize, become brittle, and they don't last very long. If you do that to a light bulb filament, in other words, you let air in the bulb itself, it'll oxidize within a second or so and be no good. So nichrome's a cool metal. The other thing that's more subtle is, and may sound weird or confusing, is nichrome is called resistance wire. In other words, it has low resistance compared to most materials, but its resistance sorry, using the wrong term, resistivity is higher than the wire that's coming in, the copper wire. So imagine I have my plug over here. Well, that plug is a cord, right? And inside is wire that's conducting electricity, and that's usually going to be copper. I don't want the copper wire to warm up. I just want it to be a pathway from the voltage source to the load. So the trick is to get this wire to have a higher resistance than the cord wire, but a low resistance in the grand scheme of things. So we're going to see that the key, the biggest determining factor for resistance is simply the material. And we need to be able to quantify that. And that's quantified with something called, I alluded to earlier, and you saw it in one of the labs, resistivity. Okay? And that's given a symbol rho. You don't have to write this down, this will be in the notes. So then the question becomes, all right, let's say I chose my material. Great, nichrome. Well, how do I get exactly 12 ohms from nichrome? There's got to be something else that determines the actual resistance. Resistivity plays a big role, but that can't be the only thing. Because if I were to have a lot of nichrome versus a little bit of nichrome, I wouldn't expect the same resistance. So there's two other factors that matter. And that's really more the geometry of the wire. And the geometry translates to two things, length and how thick it is. And the thickness is measured as area. So we could, if we come up with an equation that relates resistivity, length, area to resistance, then we can figure out exactly how much wire we need to get 12 ohms such that we draw 10 amps such that we get 120 or 1200 watts when we plug in our toaster. Okay, so like I said, the tutorial, the formal one, will sum up these ideas. We're going to go in a little bit more detail, give us an equation, and then we'll do some practice with that.